Today I'm going to show you how you can use dividers and turn a small drawing into a big drawing. These two rectangles that I have drawn here are identical. And the reason they're identical is because I used the dividers to lay out both squares. I set the dividers on the left hand side to a smaller dimension and I paced off 4 paces up for the height and 8 paces across for the width. And I did exactly the same thing for the larger square. So this gives me two rectangles that are exactly the same proportion, even though they're different sizes. So because they're the same rectangles, I can start finding locations of points within that rectangle and transfer them to the larger rectangle. Now in this example, I created both rectangles by pacing off a given divider setting. But in reality, you're probably going to be starting with the right-hand rectangle, and that's going to represent either a sheet of plywood or a wall of a room or a building, or it could be an open field if you're doing a design like a crop circle or something. So the problem is you're going to need to figure out how to define that space so you can relate it back to a smaller drawing. So here again I used a rectangle that was 4 units high and 8 units across, but you may need to find a different dimension of a unit so that the rectangle that you're working with may be 5 units high and 11 or 13 units across, or it may be 6 units high by 13. You're going to need to play around with how to define that space by measuring it with a given unit. And once you have that, it's just a matter of changing the size of the unit to create different size drawings. The next thing that you need to do is to define that scale somewhere. You either need to create a different drawing that lays out what the size of each unit is for each drawing, and then pace off a number of those units that you'll be able to use to transfer the measurements from the smaller drawing to the larger drawing. Here I'm just going to be using the baseline as the scale because the drawing that I'm working with falls well within that rectangle. But if you need to find points that fill this entire space, you may need to set up a scale that's outside of that work area in order to set up the points accurately. And then here I took one of those units and I divided it into thirds. And this allows me to define the caliper settings that fall within the whole numbers of any measurement that I take. To use this scale, you are going to need to have a second set of dividers handy to measure the exact location of where the divider point falls in between the two whole number markings. Next, you'll take that pair of dividers and see how it relates to the scale. Depending on the accuracy you're after, you may need to divide this scale into a greater number of divisions. Now you take that pair of dividers and readjust it to that same scale position on the larger drawing. And then you add this divider setting to the whole number to get the location of your point. This drawing is pretty basic, and I'm just trying to illustrate a point here, so I'm not going to go to all this trouble to lay out this drawing. And now that I have all that set up, it's just a matter of measuring from a reference point on that drawing, transferring that measurement to the scale on that drawing, and then going to the larger drawing and translating that measurement to the final dimension. So here you can see my first point falls just short of the third division on the scale. Now I'm going to go over to the larger drawing and set up my dividers to that same point on the scale. And then I'll transfer that measurement to the drawing. I'm going to transfer it as an arc because I really don't know where the second measurement that I'm going to be taking is going to cross that line. And now I'm going to take another measurement to that same point. However, this time I'm going to be using the lower right-hand corner of the rectangle as the reference point. Again, this point falls just outside of one of the whole number markings, and I'm just going to be estimating that location on the larger drawing. And I'm going to be setting up this drawing using only the lower left and the lower right hand corners of this rectangle as a reference point. And then it's just a matter of continuing this process until you have all the reference points that you need to make up the drawing. The nice thing about this system is that you're only transferring the number of points that you actually need to make the drawing. So for example, if you're laying out a sign on a wall of a building, you really only need the height of the letters and the width of each letter and the position on that wall, and then you can go and figure out from there how to draw the letters out within those points. On the other hand, if you have an area of that layout that's a little more complicated, well, you can focus in the number of points that you need in that particular area to get that part right. So say for example, if you're working with this same sign on the side of a building and there's a logo that you need to incorporate in that layout, then you can just go in and point out however many points you need to get that logo right, and then the rest of it can be a fairly simple layout. Of course, if you're working on a very big layout, you may need some help to set up these points, but the process is exactly the same. For example, if you know that the unit on your larger drawing is 3 feet long or a meter, say, and you're measuring out a point that's several units long, then it would be advantageous to transfer that to a measurement that you can lay out with a tape measure, and then have a team of people that just look after each set of measurements. Also, this system makes it very easy to cross-reference measurements within the drawing. So say for example you're working on a face, the position of the centers of the eyes is very important, so you can measure that directly, bring it to the scale, and see whether it relates to the starting drawing or not, and make any adjustments. If something's not right, well, you can cross-reference with other measurements within the drawings, or you can start working with 2 different reference points to see how they match up with the drawing. So you have ways of establishing where you went wrong in the drawing if something doesn't look right. Here, for example, I'm remeasuring this one point because it doesn't quite look right, and I did find that I was in a little too much of a hurry and the point got shifted over slightly and it threw the drawing off. So I'm just repointing that up and I'm making the correction here. Here I've taken a cutout that was traced off of the original drawing, and I'm holding it above the expanded drawing to see how it matches up. And you can see how it lines up pretty closely, even though I didn't really take a lot of care in setting out these points. I started off with an extremely small drawing so that I could get both examples on the same page, so any error on the small drawing really gets exaggerated on the larger drawing. But even still, this is very acceptable for the kind of drawing that I have here. And again, it wouldn't take much to really increase the accuracy of this drawing so that it was just dead on. Anyway, I hope this series gives you a bit of a glimpse of how life was like before the tape measure. We'll see you next time. Hi, I'm Dennis, and thanks for watching. If you like this video, by all means give it a thumbs up. If you want to support this channel, you have a couple of options to do that. The first thing, of course, is to just subscribe. Second, if you have ideas or photographs of things you'd like to see on this channel, send them along. I'll turn them into a video. If you want to lend your financial support to this channel, you have a couple of options there. You can go to my channel homepage and click on the options that you see in the banner. So thank you for your support, and with your help, I'll be doing this for some time to come. We'll see you next time.